we're going to go ahead and look at what happens when you add something to the angle. How does that graph look different? And we're going to look at what happens if you add something after the angle, as in when the x already is in parentheses and you're adding something afterwards. So let's go ahead and take our calculators. We're going to graph the sine of x and the sine of x minus 45. So we type in the sine of x, then we'll come back and we'll type in the sine of x minus 45, and we want to compare our results. Now, before you hit graph, hit the top center button and select number 7, which is zoom trig. That adjusts your window so it kind of looks nice compared to what it should be, because we're dealing with 360 degrees for one full revolution. So it, for the most part, goes from 0 over to 360 to here, and so on. So as you look at this, how does this compare? Well, as I look here, the blue is your original. That's your original sine graph. How is the red different? Well, it got moved over. And in this case, it moved over 45 degrees. So when we subtract something to the x, it's a 45-degree shift to the right. So let's do the top right one here. Let's go back and change it to a plus 90 and see what happens. Now, some of you might have an educated guess, some of you might not, but we'll graph this and see what happens. So we'll hit graph. We'll look at this. Once again, our blue is our original sine function, and we want to see how is the red different compared to the blue. Wow. I don't know, to me it almost looks like the blue has been slid over 90 degrees to the left. Hey, sorry about that. Sometimes technology is nice when it pops things up for you to remind you, and other times it's a pain. So when we looked at this graph, you saw that we were being shifted over 90 degrees to the left. So that would be a phase shift of 90 degrees to the left. Now, what happens if we would add after we close the parentheses? So let's go back here and we'll do the lower left one here. We'll go back and we'll go down to our trig function. We'll go to the sine of x. We'll close the parentheses and then we'll go plus 2. And we want to know, how does that compare to our original? So once again, the original is in blue. And then after that graph, we're going to look at the red. And how does the red coming in here compare to the original blue? Whoa, that's like shifted up. As you look here, we're at a height of 0 on the blue, then that's at a height of 2. Wow. To me, it looks like it went up 2 units compared to the original. So I'm going to go ahead and mark that and write that out. So adding after the parentheses does a vertical shift. It moves it 2 up. Now, some of you will probably take a look at the next one and say, oh, my guess is it'll be 1 unit down. Well, we can go ahead and check that. So we'll go down here. We'll go over and we'll put in -1 and we'll see what we get. So how does the incoming red compare to the blue? Well, we were at a height of 1 here. Now the red is only at a height of 0. So yes, it is down 1. So yes, adding after or subtracting afterwards does a vertical shift of 1 unit down. So adding afterwards moves it up and down. Adding in the parentheses with the x moves it left and right. So as a review from the other day, the number in front of your trig function for sine or cosine does a vertical stretch, and that tells you your amplitude. Remember, the number that's being multiplied by x or multiplied by your angle does a horizontal stretch. And then we can always use our peanut butter equation to figure that out. Our period times b is equal to 360, or our period times b is equal to 2 pi. And as we just discovered now, when you add or subtract in the parentheses, that does a horizontal shift, which we call a phase shift. And then if you add or subtract afterwards, that does a vertical shift.